Hi everyone, welcome back to part 2 of transformations. So, in this video, we're going to do a couple more examples of just moving stuff around again, and then we're going to start getting into reflections. So, for this first one, again, just like last time, we're going to start out with the parent function, which is the square root of x. It's going to be 0, 0, 1, 1, 4, 2. Those are our parent function's points. And then in this case, this 4 is on the outside and it's positive, so that means up 4. The plus 1 is on the inside, so that'll be left 1. All right, so if we move all of these up 4 and left 1, we're going to get a new function right here. Domain of our new function is -1 to infinity, and the range of our new function is going to be 4 to infinity. All right, let's try example 8. Our parent function is going to be x squared. So that was the u shape, so it's 0, 0, -1, 1, 1, 1, -2, 4, and 2, 4, with the big U connecting them all together. All right, what's happening in this one? Well, we have a -5 inside. So if it's inside, that means it's going to be right 5. We also have a +3. One's on the outside, so that means it's going to be up 3. So right 5 and up 3 for every single one of these points. And we should end up with these if we move them all right 5 and up 3. And again, draw our U shape. The domain doesn't change, still -infinity to infinity. But the range, the lowest it can go now, is 3. Okay, so moving on to reflections, which is going to be our last transformation. So keep in mind that so far, everything that we've done, it mattered whether it was inside the function or outside the function. Reflections are going to be no different. Reflections are caused by a negative. If there's a negative outside of the function, it is a reflection over the x-axis, which means a vertical reflection. If there's negative inside the function, then that is a reflection over the y-axis, so a horizontal reflection. All right, so we're going to do the same exact stuff, only now we are going to add in reflections. All right, so starting out, same thing as before, we're going to graph our parent function. So x squared again in this case. So here are our parent points and the u. This time, what is happening? So first off, we have a reflection. And since it's outside of the function, because there's no parentheses saying that it's being squared too, it's going to be a reflection over the x-axis, which means a vertical reflection. So we're going to take care of the reflection first, and then we'll move it around wherever we need to afterwards. All right, So a reflection literally means that we're going to treat the x-axis right here like a mirror. Okay, so whenever we reflect it, it should literally be on the same place on the other side of the mirror. So like this point right here, -2, 4. Right now it is 4 away from the mirror on this side. So it should also be 4 away from the mirror on this side. -1, 1. Oops. Should be 1 away from the mirror. 0, 0. It's touching the mirror. So just like whenever you touch the mirror with your finger, it looks like your fingers are literally touching. Same thing here. The graphs are actually going to touch on the mirror. 1, 1. And 2, 4 will be down here. Still the same U shape, but now upside down. All right, now here's the thing. We are not actually done yet. Because remember, we still have this +1, right? That means we need to go up 1. So every point that we just got, we're going to move those up 1. And then we're going to redraw our U. So the blue one is the final. All right, what's our domain? Still the same thing, -infinity to infinity. Our range has definitely changed though, because now our lowest point is actually -infinity. It goes down forever. Our highest point is 1 now. All right, let's try another one. So for example 2, we have the square root of x. That's going to be our parent. So 0, 0, 1, 1, 4, 2. And we make that little eyebrow shape. All right, again, 2 things are happening to it, and we're going to start with the reflection. So that is a reflect over the x-axis again. So reflecting it over the x-axis, we're going to treat the x-axis like a mirror again. We just want to make sure that every point reflects across. And it's now going to be a little upside down. And the green one is our new one so far. But again, just like before, we're not done yet. We still have this -3. So the -3 is going down 3. So from our green one, we're going to move every single point down 3. And then we're going to draw that upside down eyebrow again. The domain of our new function is going to be 0 to infinity. And the range, will be -infinity all the way up to -3. All right, don't worry, we got plenty more examples. So next one, x squared again. So that's the U shape again. So 0, 0, -1, 1, 1, 1, negative 2, 4, 2, 4. Draw the u. All right, next up, reflection. We have a reflect over the x-axis again. So we'll do that first. And again, it's just going to flip this upside down to where if you fold your paper in half right along the x-axis, these two should be perfectly on top of each other. Next up, we have two different numbers here. That's just going to move it around just like we were doing before. So that's going to be to the right 3 and up 2. So if we move all of these right 3 and up 2, and draw that same upside down U shape, and we should end up with something like this. The domain is negative infinity to infinity. The range is negative infinity all the way up to 2 is the highest. All right, next one. We start off again with the square root of x. 0, 0, 1, 1, 4, 2. Draw the eyebrow. Next, we have a reflection again, but this time, and if I scoot over a little bit, we have a reflect over the y-axis, because it's inside the square root this time. So this time, the y-axis is going to be our mirror, meaning everything is going to shift left instead of upside down. We have an eyebrow going to the left now. All right, last thing that happens to it, we have a minus 4, so that is down 4. If we move all of these down 4, we end up with it right here. So our domain is negative infinity all the way up to 0. And our range is negative 4 to infinity. All right, for these last two, I'm going to go ahead and have these as a practice for y'all. So if you want to go ahead and try them out, pause the video, try them, see what you get. In another like 5 seconds, you will see the answer pop up on your screen. All right, and here is the answer. For both of these, the blue is the final answer again. So again, pause the video, make sure you're okay with these. And as long as you are, we're going to go ahead and move on to the last ones. So this is going to be the same exact idea, only now, instead of having to know the parent function, I'm just giving you a function, and you're going to be moving it around accordingly. Okay, so given that this is f of x, so this is like your new parent function, we are going to do these different things. So let's start off with A. A is f of x minus 2. Just so we have these, f of x minus 1 plus 3 is going to be b, and negative f of x plus 2 will be c. Okay, so what is happening to the function in this one? Well, negative 2 is on the outside of the function. We know it's on the outside for sure because it's not in the parentheses. It's not attached to x. So that just goes down 2. So each one of these points, we're going to move down 2. And then we're just going to play connect the dots to recreate the shape. For B, same exact idea. Only now there's also a negative 1 on the inside. That is going to go right 1. And the plus 3 goes up 3. So for each of these points, we're going to go right 1, up 3. Again, play connect the dots, and we got our same shape. For the last one, we have a negative this time, which means we need to do a reflect over the x-axis because it's outside. So if we reflect it over the x-axis, remember this is our mirror. So to reflect the first point at negative 3, negative 2, it's now going to be at negative 3, positive 2. 1, 2 is now going to be 1, negative 2. And 3, 1 is now going to be 3, negative 1. So this, if we play connect the dots, is our new function so far. I say so far because we still have one more piece, the plus 2, which is going to bring it up 2. So from our new function, we're going to take every one of those points, move them up 2, and play connect the dots one last time. And that blue one is our final answer. All right, so hopefully you know how to do some transformations now. Just remember, for this, the 3 that you need to know are vertical shifts, horizontal shifts, and reflections. As long as you can do those 3, you're going to be good to go for this course. All right, with that said, that is all for this video, so I will see you in the next notes. Thank you.